So I'm going to talk this morning about DNS RPZ, kind of also known maybe as a type of DNS firewall. So it's kind of a technical topic. It's a pretty technical presentation, but it also tried to throw in a zombie theme to kind of keep it a little bit lighter and interesting. So my name is Vincent Stoffer. I'm a cybersecurity engineer at Lawrence Berkeley National Lab. What I want to talk to you about today, I'll give a quick overview, talk about the problem we're trying to solve with the DNS firewall, go into kind of a deep dive, technical dive on RPZ, talk a little bit about how we've done it at the lab. I don't think I'm going to be able to do a live demo just the way the laptop got set up, but I got some slides that kind of replicate what I was going to do there anyway. And then hopefully have a little time for questions at the end. So LBNL is located in Berkeley. Our motto is bringing science solutions to the world. We are a DOE research lab that is operated by University of California, and we do science in a broad variety of areas. Focus on physical sciences, biosciences, computing, whole bunch of interesting stuff going on at the lab all the time. We operate a lot like a research university because we're so closely tied to the University of California. You know, here's the picture of the campus, and if you're familiar with Berkeley, there's a stadium, and you know, Berkeley Lab sits right above it. So we have a whole bunch of you know, researchers at the lab that are also professors at Cal, and tons of grad students that are, you know, working from the university up at the lab. So I don't know, we may operate differently than you think of as other kind of national labs, which do a lot more kind of, you know, the weapons research and that sort of stuff. We function a lot more like a research university, I think. Just to give a kind of overview of our site and size, we're about 5,000 users and 10,000 hosts on the network at any given time. Pretty distributed computing resources. So each kind of division or department or even lab might have their own servers and, you know, operations staff, and IT security is very centralized. So on my team, we're managing security for the whole lab, but in terms of the rest of IT and support and that sort of stuff, almost anything goes, which makes for an interesting cybersecurity environment. We have a ton of guests and visitors, so we have people coming from all over the world to use the facilities at the lab. Sometimes people are only there for half a day or a day. So they may come in from across the world. They may have their time on our advanced light source beamline for 12 hours. So they may come with their laptops, set up, do their experiments, need to connect back to their home university or wherever they came from, upload their data, and they're gone 12 hours later. So if we had a really restrictive computing environment and cybersecurity environment, that would make it really hard for science to get done. So a big part of our philosophy of cybersecurity is an open network to enable science, because that is our job as IT and cybersecurity, is to enable science at the lab. So we have quite a different environment than a corporate environment. We have no border firewall. We operate a lot of router blocks at the edge. So cybersecurity, my group takes care of those, of watching our intrusion detection system, doing kind of dynamic blocking at the border, but we don't have a deny all at the edge. So almost anything is allowed in and out of our network. So that keeps us very busy in our group. We're a small team of about 5 folks, and we handle all aspects of cybersecurity and e-discovery for the lab. Again, we focus on kind of these border protections because of the way our network's structured. We have to be really focused on watching the edge, catching intrusions when they happen, and doing remediation and cleanup as fast as possible. That's kind of another part of our philosophy. We use BRO, which is a network security monitor intrusion detection. Can be called a number of different things. It was actually started by a guy who was on the cybersecurity team at the lab. It's now expanded. It's getting a lot more kind of interest in higher education and even in some corporate environments. So we use Bro for almost everything involving cybersecurity. That means incident response, forensics, this sort of active blocking technology that I'm talking about. All of that is usually handled through our intrusion detection system or Bro. And our group works closely together with our networking team, so that's important just in terms of how we do the blocking and tracking down users quickly, that sort of thing. So the idea is we've got problems. We've got zombie hordes coming at us, right? And those are all sorts of threats, from malware to phishing to you name it. Whatever cybersecurity problem is out there, we probably have seen it at the lab. So specifically in terms of DNS problems, these are some of the threats that we're trying to address with something like RPZ. So domain generation algorithm, this is where a piece of malware will create abc.com, and then the same algorithm will create def.com, efg.com. It could be a 16 character string of numbers and letters, could be random stuff. You look at this stuff and you think, what could have registered a domain like this, or what could be using this? Well, it's probably just an algorithm that's embedded in this malware to make it harder to track down. So, keeping track of all those sorts of names and updating them all the time can be really difficult depending on your situation. Something like RPZ makes it easier, and I'll explain that a little bit. Fast flux, same thing, kind of rapidly iterating through domains or IP addresses. Malware is certainly known to do that. I watched a presentation at DEF CON this year, and the guy was talking about fast flux and had done a bunch of research recently into how much change was happening over those domain names and IP addresses. So he said basically it's kind of slowed down. There was this kind of high point where the fast flux guys were just changing every minute or every 5 minutes, wherever these domains were rapidly changing. Now he said they've kind of backed off. They realize that's not as effective for them. They have to keep registering all these domains and dealing with all the churn. So they still use it as a tool, but it's backed off a little more. They may continue to use some of those same name servers, register all of their malicious domains through a particular name server, which gives us a foothold in RPZ to start blocking those. I'll talk a little bit about that. But I think it also just gives the opportunity to be able to block a little more effectively on some of those malicious domains since they're not changing quite as rapidly. So another DNS problem is phishing. We see tons of that stuff, right? Just the generic kind of bank and every other kind of site getting phished, but then also targeted phishing, which is one of our biggest threats at the lab. We've had a number of campaigns targeted against us, either to specific people at the lab. This is from the director, click on this, to a malicious link, or recently we've also seen some of those kind of what they're calling waterhole attacks. So they compromise the site that they know specific people in the lab might be going to on a regular basis, and then don't even need to send out an email. They just kind of wait for people to come to this watering hole, and then there's a malicious infection vector on that web page. So if it is sent up via link in an email, and that's something that someone's looking up with DNS in our environment, that's something we could block via RPZ. So I'll talk about that. And then just generally malicious domains that are kind of shared out there among people, right? There's compromised sites, good sites running WordPress or whatever, they get easily compromised and used for malicious activity. We have malicious ads that are running on legitimate sites, the kind of Russian roulette stuff we've seen. You go to CNN, 10 times you're fine, but the 11th time you get a bad ad, and that could infect your machine. So also there are lists, and we're using some of just malicious or evil name servers, and these are operating domains that are all bad. So I'll talk a little bit about how RPZ helps us address name servers as opposed to domains, and why that's one of the really powerful things that RPZ does. So again, I talked a little bit about blocking, how we do kind of blocks at the border. We do those in a couple of different ways. So we block just IP addresses. So if you scan us, you do a certain number of attacks, you do specific things we're looking for in our intrusion detection system, we'll just block you by your IP address, right? You'll stop being able to attack us. We had the capability to do net blocks, so we might block a specific network that we know is bad, or some test networks, or the ability to kind of operate on a net block. So if someone says, hey, we're going to this conference, we need you to whitelist this whole net block. So we had the ability to block on not only IP, but a net block. We also have two other capabilities. One was kind of an IP to IP thing. These are both, we're not really using these anymore, but I just kind of wanted to mention them as capabilities we had. But say IP to IP, so if you went to, say, an inappropriate site, for a while we were making it so, okay, we just block your IP address's ability to contact that one site. So you could get to the rest of the internet, but if you tried to go to this malicious site or this inappropriate site, you would just be kind of blocked for 10 minutes from going there. So you'd be like, oh, okay, try it again, wouldn't work, okay. Off to do actual work, maybe. And then we had the ability with Bro to do some URL blocking. And this was kind of the beginning of our ability to block on domains, but it was pretty limited to a single file. You had to go in and edit, you had to go in and add this stuff kind of manually, you might have to restart Bro. You had to do a bunch of stuff that didn't make it easy. So prior to us using RPZ, this was kind of our blocking. We didn't have a way to easily block domains. We're not using a web proxy, as I explained. That kind of doesn't fit into our environment, so we don't have an easy way to do it there. We didn't have a great way to do this. But at the same time, we were getting lots of rich DNS data from partners, from even just reports internally our organization of bad domains. So we kind of said, well, how can we add this kind of DNS black holing, firewalling, whatever you want to call it. People call it a lot of different things, but whatever you want to call it, it is just kind of using the domain name system to block bad domains, or even more in the case of RPZ. So some of the existing ways people do this, a simple blacklist zone, right? I'm mostly going to talk by RPZ is a bind function, which is the open source DNS server, which is probably the most popular one in the world, but certainly there are others out there. But you could use a blacklist zone in any DNS server. You could just put in a zone there that is referenced anytime someone does a lookup from your institution and says, hey, if you see this domain that's in my blacklist, just don't answer, or tell them they can't go there. So there's a way to just put in a zone, type stuff in there, and kind of manually add things one at a time. Another bind feature is called dynamically loadable zones. So this kind of expanded on the idea of a single flat file of just a blacklist into a database-backed blacklist. So it made the ability to add kind of bulk domains easier. You didn't have to restart the name server. There were some other functions that made it kind of, okay, now we're one step closer to automating this and making it easier to add a lot more than just, say, a single or 5 little lines at a time. And another option would be, to use a third-party refer cloud service, OpenDNS, something like that. I know companies and lots of home people use that, and that's a great way to be protected from DNS because they're essentially using all this same technology on their end and filtering your DNS queries through the same sort of methods. But a couple drawbacks to some of those solutions are restarting the name servers is often what you had to do with these blacklist zones. So, you're operating a DNS server serving thousands of clients, and every time you want to add a new domain, you have to restart your name server. Well, that's not going to work, right? It just means downtime, and the larger those zones get, the longer it takes to restart your name servers. We heard people saying, once I got thousands of domains into one of these zones, it might take 30 seconds or a minute to restart my name server. So unless you have some sort of failover, redundant system built up, this just isn't going to work, right? Slow zones loading. Pushing out or syncing zones was difficult. There's not an easy way to synchronize across multiple name servers if you did have that with, using these single zones. Performance issues, lack of flexibility, and in the case of something like OpenDNS, passing your DNS data off to someone else. Like, do you want to be handing off all your domain queries to someone in the cloud? I don't know. It's up to your individual organization, but that might be something that you don't want to do, and you kind of want to be able to control this locally at your own site. So here's a suitable zombie weapon, right? We're going after killing the zombies. This guy had a great web page talking about how he designed this thing himself. And anyway, so what I've described, I think, so far is a suitable weapon, but you're there out in out in the hordes with your baseball bat looking thing going after them one at a time. It just seems like we could do a little bit better, right? So we started investigating bind RPZ. And what that is called response policy zones. Again, it's a bind specific feature, so this isn't going to work on a Windows DNS server. This is specifically about bind. But there's a number of ways if you are using Windows or other DNS servers to kind of wedge a bind DNS server into your environment, even RPZ, putting it at the edge or as a refer or whatever. So there are some interesting ways that you could wedge that into your environment no matter how you're doing your DNS system. But essentially it's policy within a special DNS zone. So it allows the name server to rewrite the responses based on what you have specified in this policy. And we'll go through that in great detail here. So a couple of the other really cool things is zones can be exferred, which in the bind lingo means they can be transferred between servers in an incremental way. So you can say, I'm going to share this RPZ zone with my 2 other name servers in my institution and also my 4 friends over here that want to receive it. And it doesn't just send the bulk list of 40,000 domains every time. It'll send it once, and then every time you request it after that, it'll do incremental updates. So it allows for a really low volume, instantly updating method for synchronizing DNS zones. So that was something that was not available before RPZ in terms of blacklisting. And I think the idea was kind of started to have an easy way to share it among everyone or to be able to subscribe to third-party kind of feeds from other people, say OpenDNS or someone else could create a zone, an RPZ zone, and then you could purchase access to it or share it amongst your friends or whatever. So that was the idea. It is a draft internet standard. I think it's gaining more traction. I've talked to a lot of people that are using it more recently. And the reasons are these killer features, right? The triggers can be based on multiple values, so it's not just query. So it is not just baddomain.com is in this RPZ, and now I'm going to tell the person requesting it they can't look up this domain, right? We're going to go through some of the other ways that RPZ can actually function on different types of queries, different types of things in the DNS record. So you're not limited to just the query, and that's really one of the most powerful things. And the policy can have different results. So if I had A.com, B.com, C.com in my policy, I could have something different happen for each one of those. I could say, when you see A.com, do one thing. When you say B.com, do nothing. When you say C.com, do something else. And I'll go through a little bit about what those things you could do are. But you can, for each domain or each policy that you have in there, you could have a different response, which is pretty neat. Again, the incremental transfers, that's very cool. No restarting bind. So this all takes place just, as everything's running, you can make changes, and these zones are dynamically updating and being able to be loaded and shared and everything else. And multiple zones can be referenced, so you're no longer limited to just a single file or even a series of files. You can have these pulled in from different sites and sources, and then have them, being acted on in different ways. So now we're talking, right? We got a little better weapon. We're going to be able to get out of the fray into something a little safer. Be able to go after a few more zombies at a given time. So quick DNS refresher. I'm just going to show you how RPZ actually acts. But generally, what happens, right, is a client, which is a resolver, will ask a recursive name server, which is probably the name server in your institution, what a particular IP address is for a domain. So what's example.com? That recursive name server within your institution will go and iteratively follow the chain of DNS servers to find the answer. So here's the DNS client at the bottom. He asks his recursive name server, hey, who's www.example.com? The recursive name server will go out to the root name server. We'll say, I don't know, but ask who .com is. Okay, here's .com. Ask .com who example is. We get to the example.com name server, on and on. That will iteratively go down until we find the answer to our query. So here is where RPZ acts. So the recursive name server actually does all of that work. It's still, if you say who's example.com, it's going to go through the entire iterative process. And then the policy is going to be enacted right before it goes back to the client. So the RPZ takes place right there. So a couple implications for that, but first of all, there's no change to the actual data, right? The actual data of whoexample.com is still sitting in the DNS server's cache. I can actually go and query it, which is kind of interesting. Also, there's no exposure to anyone outside that anything's being changed, right? If I ask for example.com and I'm a bad guy, or I'm watching queries, to this name server, I'm still going to see the query come. So there's no real exposure to know that someone might be using this necessarily. Okay, so I'm going to go over the triggers of RPZ, and again, these are the things that you can act upon in a query to trigger something to happen. So QName is kind of the bread and butter blocking. It's regular DNS records, and these are expressed in terms of policy just like they are here. So a regular DNS record could be any one of these things, right? These are all different. www.badguy.com, badguy.com, and splat.badguy.com. Those are all different record types, and they're all going to match on to different things. So the one thing is you need to make sure and be explicit about your policy when you're expressing this, right? If I just put in www.badguy.com into my RPZ, and someone goes to badguy.com, they're not going to get blocked. This is more explicit, and this record's going to match on only this one, but not anything else. So you end up having to make sure, if I want to really sinkhole an entire domain, I'm going to want to do badguy.com and splat.badguy.com. That's then going to get everything. That was one thing that kind of caught us when we first started using it. It was like, oh, okay, well, we'll put in badguy.com. Yep, we're done, right? It's like, no, this is not matching. This works just like a regular DNS record. So another nice thing is the query names will also be triggered in a response with a CNAME request. So if I go to badguy.com and there's a CNAME to www.badguy.com, then that will actually be triggered. So any CNAME requests that are followed in the chain of the query will be rewritten. One of the very cool features is an IP. So I can now match an IP in the response record of the DNS query. So here we go, asking for badguy.com. This is a real domain, right? I just looked it up. Yep, it's a real domain, and here's the IP address. Instead of putting badguy.com in, if I put in this address, 621.16.181.25, into an RPZ policy, every time RPZ sees any record come back with that IP address in it, it's going to block it. It's going to act and it's going to say, I see that IP address is acted on in my policy, and I'm going to do whatever you want me to do with it. So if he had www.badguy.com and www.2.badguy.com and mail.badguy.com and everything else is all pointing to that same IP address, all I'd have to do is put that IP address in once and they're all gone, right? So this is a really powerful feature, being able to block on IP address anywhere in the record. So again, here's a look at google.com, right? We get all these different IP addresses. When I query google.com, well, I could block all of those, but it's just an example of how a single record might spill out to a number of IP addresses. I could act on an entire net block if I wanted to. So client IP is a little interesting. It's actually just the address of the querier, right? Who made the request. You can act on that. So we've used this a little bit, started messing around with it internally to say, hey, this particular business unit or this network or this one person, when they make a query, we want it to match and we want to send them off somewhere else. I don't know. We haven't really explored how we could use that, but I'm thinking isolation or just internal redirection, just one more piece that you can match on to do policy, but it's also, again, kind of a cool one. The last two are both to deal with name servers, and again, this is one of the really cool features of RPZ. I can match on the authoritative name server for a particular record. So instead of badguy.com, if I put in an NSD name record for ns1.badguy.com, that means anytime I do a DNS query that comes back with this authoritative name server, I'm going to block all those records. So again, this is specified. This one, the NSD name is the name. So the next one is the IP address, but same thing, right? Whether you use IP address or whether you use name, these are going to block on the authoritative name server. So again, we've seen a lot of this where the bad guys are using the same series of authoritative name servers. They might register one set of authoritative name servers, ns1.badguy.com, and they might have 1,000 domains that they're using off of that same authoritative name server. But again, with RPZ, I put in one single line And I've blocked all 1,000 domains with absolutely no effort. And not only with no effort, the next week, when they decide they're going to register 5 new domains and still use the same authoritative name server, I've already got them blocked. So I'm already blocking stuff that the bad guys haven't used yet. They may not even know they're going to use yet, but if they're going to use this same authoritative name server, we're going to already have them blocked. So of course it's not a catch-all. Of course they can use different name servers. They do fast flux name servers in the same way, but we're seeing that a lot less. Again, we're seeing that churn slow down in terms of the name servers being fluxed. So I think this has been something that's really effective with RPZ and one of the cool features. Okay, so here is just, I guess, showing the name server trigger, right? So here's the additional section. The authority for google.com is these 4 name servers, and here's the additional records showing those IP addresses. So again, I could block on any one of those. I could block on nsplat.google.com in a name server record. I could block on the IP addresses. However I choose to do that, I could affect those records by acting upon those authoritative name servers in several different ways. So we've got a way to target some of the zombies a little better, right? Kind of explained to you some of those triggers, how we match them. A lot more flexible, I think, than anything else that existed out there before RPZ. Couldn't match on all of these different types of things inside a DNS record. It was basically just like, you want to match a domain? Okay, you can match a domain. Anything else? We don't have a way to do that. So we've got a much better way to target. Now what do we do, right? So I'll quickly go over some of these responses and what you can do once we've matched using one of those policy triggers I described to you. So we've matched in any way using one of those. Here's what we can do with it, right? So pass through is just don't rewrite, don't do anything. Great if you have, a particular whitelist you want to use. This is what you might use. If you had, say, I don't know, a same thing, but say you had a splat.domain that you wanted to blacklist, but then you put one of these in front of that. So same thing as a whitelist, but say you just wanted to do a single record, you could do that. So don't rewrite anything. Drop the query on the ground, which is just don't respond at all. Don't give an answer. It's as if you never asked. The name server just won't respond to you at all. NX domain is the typical error returned by a DNS server if no record's found or there's some sort of error. So this is going to just return an error. Sorry, can't answer your query, error. And that's pretty typically how you might use a blacklist, is just return the NX domain. No data is, I don't know, slightly strange since there's the drop and error and then no data. I guess this does return a record that says there is no data, right? So I don't know, it's about the same thing. And then local data is the powerful part because we can return the data of your choosing. We can now rewrite that record to be whatever we want locally. And so often I think you'd use either the NX domain, which is just like, okay, DNS error, there's a problem here, or rewrite it to some sort of local walled garden, and that's what we're doing. We started with the NX domain approach, just saying, we'll put all this list of domains in and we'll send an NX domain to our clients, but that doesn't have the great, advantage to the clients because all they get is an error, right? And if they're in a web browser or something else, they don't know what happened. It's just they may get an informational page from the browser saying there was some problem. If they're on something else like SSH or some other kind of protocol, they may not get any error at all. It just is something doesn't work and they don't know why. So we quickly realized that NX domain was probably not the right way to approach the users with this. And we started going to redirection to a walled garden, and I'm going to show that in a minute. So here's a test query on our network for rpztest.com, which is also a real domain, but I needed some sort of test. I'm like, well, this is good. I look it up, and it's like, oh, it actually has a real address. Someone's registered this. But this is showing that it is redirecting to block.lbl.gov, which is our internal walled garden, and I'll show you the page for that in a minute. So if you did this query on our network right now, this is something in our RPZ, and you would get a CNAME to blocked, and that's what you'd receive as your answer. So our implementation, we started about a year and a half ago, something like that. Right now, I just checked. I had to update the slide because we've got about 40,000 domains in there. And that includes, splat.domain. So that encompasses a whole lot more domains than just 40,000, but that's about what the list is in terms of just line count. We're using just the local zone right now. We're actually evaluating one of these third-party feeds that you can get from someone else, and I'll talk briefly about that. So we've got the local zone with all of our stuff in it, and then we are experimenting with how we can bring in an external zone. So that's pretty cool. And I said we started with the annex domain. Now we kind of send everything to a captive portal. So where do we get our info? We get stuff from DOE. There's a bunch of information that flows through down the government chain through DOE that we get. We put that stuff in there. We have a bunch of trusted partners and security groups that we're a part of that share DNS malicious data, so we pull all that stuff into our RPZ. We've got internal discovery. We've got Bro finding interesting domains that are malicious. We put those in there. We get, every time someone sends a message to security saying, hey, I think this might be a phishing message, right? You get those all the time. Well, it takes me 5 seconds to just copy paste that malicious domain into my RPZ and hit apply, and it's in there and blocked for all the rest of the users. So that sort of quick feedback is awesome. Being able to have something like RPZ, you can just drop any old malicious domain that you find in there, whether it's from a blog you're reading, a security blog, or something someone told you, or something you find out on your own, put it in RPZ and it's done. It's blocked for the rest of your users. Third-party feeds, talk about that in a sec. So some of the lessons we learned so far doing this, the feedback loop is super important. I was a huge proponent in talking about how I thought we really had to go beyond the NX domain thing and get information back to the users, explaining a little more about what was going on. The input data quality matters, right? You don't want to be blocking domains that people are actually visiting, so it's important to have a whitelist and be able to kind of have a way to easily pull out a domain that's legit that you're blocking. The false positives are inevitable. I mean, we definitely have those. We have a spreadsheet where we kind of track all the ones that we've pulled out of our RPZ. For some reason, someone said, hey, I got this message from you guys. It's blocked. What's going on? So, we'll do a quick check. Oh, sorry. Yep, that was a mistake. Put it in the whitelist. And valuable data has been gleaned from the instrumentation of this for sure. We can see the number of domains people look up, the number of malicious domains. We can kind of do a bunch of statistics on that. I think there's another part in the slide, but we catch infections with this too. So I showed you the redirect to blocked, so that's where everything, at least over HTTP, HTTPS, we've got all the common ports there, proxy ports, all that stuff. So if you're using our name servers and you go to one of our RPZ domains, you're going to get redirected to this site. So here, if you went to rpztest.com, just a little quick page, really simple text. We didn't want it to be complicated. This icon right here is like a clickable icon. So our idea was if this loaded up in an ad or on a mobile browser or something like that, you'd still have something. You'd be like, oh, okay, if you clicked on that, it'll take you to this same explanatory page here, which is just a little more information about what we're doing, why we're blocking that. So that's what someone will see initially if they click on it, or go to one of these malicious domains, and then click here for more information. Again, I'll leave that up for a second. It's just a little more explanation of what we're doing and how you got there. And I think the biggest part is, several times we have please contact security@lbl.gov if there's a problem. That's what we wanted. We wanted people to see, hey, I've been blocked, and here's how I contact security if I think there's a problem, because we don't want you to be blocked if it's a legitimate site. And when someone writes and says, hey, I'm trying to go do my job, and I went to this science site, it's blocked, what's going on, you guys? We want to fix that in as little time as possible. So this has helped do that. We have another site at the lab called One Stop that's pretty well known to our users, and since we use this kind of dynamic firewall, this dynamic blocking that I described, we need to have a place that people can go and say, is my IP blocked for scanning, or I'm coming from outside the lab, I think something's blocked. So we have this site that now supports RPZ that people are kind of aware of. So if you put in a domain, rpztest.com, it now supports RPZ too, so it'll go out there, check if it's RPZ and tell you. So that's just one more piece of feedback we can give our users if they go to this site to check for a block, which they would kind of normally do for an IP address. They would see the same info for an RPZ. And we get a report nightly, what domains were rewritten, what clients did the lookups. If there were refers, we get to see those. And this is the place where I said we've caught infections, right? We've looked through this report every day, and you know, if all of a sudden one client is making a request to 50 malicious domains, it's pretty clear to tell. You see the full URL in there they're looking for. So we easily catch infections that antivirus didn't catch, that no other kind of thing caught, because it escaped all of the other protections, and yet we were still able to catch it just with this RPZ system and our feedback loop. It's pretty cool. So getting close to the end here, a couple more slides. Future enhancements, what we want to do, we want to get more data. We want to actually be able to use Bro on the web host on block to kind of capture a little more data from the clients as they're redirected, and that includes kind of doing some sort of honeypot. So right now, we're getting the web traffic, but what about the other protocols? I'm really interested in kind of getting all the malicious activity that comes to these redirected sites. So we'll be able to catch advanced malware, stuff that no one really knows what's going on, because you may not have any visibility into it any other way, but if it's on our network and it's contacting our redirect site, we may be able to capture that traffic, or at least the destination IP addresses or something that might give us a little more information into a new infection. So that would be cool. Better feedback to our users, I think, would be great. A little more context, maybe. We've talked about other protocols. If you were SSHing, maybe it would give you a banner saying, you've been blocked. Just, I don't know, a little more there, I think. And we're tracking RPZ improvements, just it's continually evolving. This stuff's changing pretty fast. So we're just kind of watching that and seeing what else gets out there. And we are exploring the external feeds. So we've partnered with a lady who is just tracking malicious name servers, again, one of those cool features of RPZ. And we're working with her to we're in logging only mode now, so we're using her domain, we're watching all the stuff she's matching on and hoping to roll that into production pretty soon. So she's getting good feedback from us on what we think may be false positives and stuff, and in turn we're getting all of her rich data of malicious name servers, and hopefully, again, blocking clients connecting to domains that may not even have been registered yesterday, but because we have this feed, we're going to be protecting them. Just some performance numbers on our stuff, where this is the version of bind we're running. We've got 3 servers in an anycast configuration. We have 5 enclaves around various other places that also use our DNS RPZ feed. About 750 queries a second. Paul Vixie, who's one of the creators of Bind, says that there should be about a 15% performance hit. We don't see a huge hit yet, but again, I think because we have this all in a single zone, that may have limited our performance impact. As you increase the number of zones, it does increase the number of lookups that have to be done, because each one of those zones is going to have to, do a lookup internally. So I don't know. We're kind of waiting to see how that works. Not going to do the live demo, but you kind of saw what would happen if I went to rpztest.com. It would have been kind of cool to show you live over our VPN connection that it would work the same way. But you would see that page. You'd be redirected there. So pretty neat. How can you get started with RPZ or get it into your organization? Basically, you just have to be running a pretty new version of Bind. It's not like bleeding edge, but 9.8 is pretty recent. But with all the vulnerabilities and stuff that are always out there, you probably want to be running a pretty up-to-date version of Bind anyway. So make sure you're running a current version of Bind. Start with a small test zone. You could do the NX domain like I described. Don't have to get into the redirection and all that stuff. It would just be kind of quick to set up a blacklist. Add a whitelist there so that if, you don't shoot yourself in the foot, or you can experiment with kind of doing the whitelist blacklist thing and putting stuff in there, and maybe even consider a third-party feed. Both SpamHost and Serble, a couple other people are offering RPZ feeds right now. Whether they're malicious, they have a couple different flavors. There's malicious IPs, there's malicious CIDR blocks, I think, as Serble has one of those, SpamHost has one of those. So a couple things you could explore there. And then got some references, so I think these slides will be up on the site at some point. Click through there and take a look, especially the first one. This is a site that some of the RPZ folks set up, DNSRPZ.info. If I was going to say just one site, if you're interested, go to that site. It's got a whole bunch of links to almost all this other stuff. And that's it. So happy to take any questions. And there's my contact info, or you can write us at security. And happy to answer any questions about any of this stuff. So thank you.